Now let's come up with some equivalent fractions. First thing I want to do is to write 4 fractions that are equivalent to 3/5. So let's start with the fraction 3/5 and come up with another fraction that's equivalent to it. Now there are all kinds of ways I can do this. All I have to do is to multiply my numerator and multiply my denominator by the same number. I can pick any number I want. Let's start with 2. That's an easy one to multiply by. So I'm going to multiply each part of my fraction by 2. If I do that, I'll get 6/10. And that's a fraction that's equivalent to 3/5. Let's try another one. Let's multiply each piece by 3. I'll come up with 9/15. 9/15 is equivalent to 3/5. It's also equivalent to 6/10. Let's start with 3/5 again, and this time let's multiply by something else. Let's don't go in order this time. Why don't we skip and say we're going to multiply both by 8. Three times 8 is 24. 5 times 8 is 40. So 24/40 is a fraction that's equivalent to 3/5. This time let's multiply by 100. You can pick any number out you want to multiply by. 3 times 100 is 300. 5 times 100 is 500. So 300 over 500 means the same thing as 3/5. So I can actually say that 3/5 is the same as 6/10, is the same as 9/15, is the same as 24/40, is the same as 300 500. We're going down the paper on. These are only 5 or 4 fractions that are equivalent to 3/5. We could find just as many fractions as we wanted to by multiplying the numerator and denominator by different numbers. As long as you multiply both the numerator and the top by the same number. Now what this really means is, if I took a circle and split it up into 500 little pieces and shaded in 300 of them, what I'd get would look the very same thing as if I took a circle and split it into 10 pieces and shaded in 6 of them. If I could actually split it up into 500 pieces and shade in 300, the portion of the circle that I would have would be the same as the portion of the circle I would have if I just split it up into 10 pieces and shaded in 6. Let's practice with this one more time. Write 3 fractions that are equivalent to 9/11. This time let's multiply, first of all, each piece of the fraction by 5, and we'll get 45, 55. Let's multiply each part of the fraction by 7, and I will get 63 77ths. And we can multiply by anything we want. We didn't use 2. Let's multiply by 2. But we have to multiply both pieces by the same thing, or we won't come up with something equivalent. This would be 18/22. So all of these fractions mean the same thing as a fraction 9/11. We've just built them all up so that they have a bigger denominator and a bigger numerator. Sometimes we're asked to do something like this. Write a fraction that is equivalent to 3/4 but has a denominator of 20. So we want to start with 3/4 and change 3/4 into another fraction that's equivalent to it or equal to it, but this time we want our denominator to be 20. In order for us to do that, we have to decide, well, what do we multiply 4 by to get 20? Well, we can tell that that's 5. So if we multiply 4 by 5 to get 20, to keep the top equivalent to it, or to come up with an equivalent fraction, we've got to multiply that top by the same thing too. So if we multiply it by 5 also, we'll get 15. So 15/20 is the fraction that's equivalent to 3/4, but has a denominator of 20. Sometimes you'll see one written in which the denominator is already down there. We want to change 5/9 to a fraction that's equal to it, but has a denominator of 99. So again, you have to think, well, what do I multiply 9 by to get 99? Well, if you can't tell, you come over to the side and divide 9 into 99 and see. We'll go one time. Now I'm going to 9 one time. So 9 went into 99 11 times. So 5/9 is equal to, well, I'm about to go too quickly. What I was trying to do was to see what I have to multiply 9 by to get 99, and I found that I had to multiply by 11. If I multiply the bottom by 11, I've got to multiply the top by 11. So you come up with 55/99. Now I want us to look at a couple more that are a little bit strange. And this one, we want to change 6 to a fraction that has a denominator of 3. So I'm going to change it to a fraction that has a denominator of 3. Well, the only way I can do that is write 6 where 6 looks like a fraction. To do that, I have to put a 1 under the 6. 6 over 1 looks more like a fraction, but it still means 6. Now I can say, what do I multiply 1 by to turn it into a 3? It would be by 3. If I multiply the denominator by 3, I have to multiply the numerator by 3. 6 times 3 gives me 18/3. So 6 can be turned into 18/3. Another kind of strange one is to take 0 and write it as a fraction that has a denominator of 7. Well, we can put a 1 under the 0 and make 0 look like a fraction. 0 over 1 is still 0. And then we say to ourselves, what do we have to multiply 1 by to turn it into 7? We'd multiply it by 7, and then we'd multiply 0 by 7. You have to multiply them both by the same thing. Okay, you can't really see this, so you need to listen carefully. We're multiplying 1 by 7 to get 7, so we have to multiply 0 by 7, and that gives you a 0. So 0/7 would be representing 0 as a fraction with a denominator of 7. And then here's a mixed number. If we want to change 1 3/5 to 1 and something 25ths, we'd really just be working with the 3/5. So we take the 3/5 and turn it into so many 25ths. And we'd say, what do we multiply 5 by to get 25? And that would be 5. So we'd have to multiply 3 by 5 and get 15. So we come back over here and put in the 15. So 1 3/5 is the same as 1 15/25.